Hello everyone, welcome back. Today we are going to discuss about the continuation of this worksheet, which is all about inequalities, and then we'll talk about mixed questions on trial and improvement together with inequalities. So without further ado, let us begin. Let us keep some boundaries over here. Okay. Cool. We are given that x plus 5 equals 0. We are given x plus 5 equals 0. State whether these statements are true or false. Okay, let us solve for x here. Let us solve for x here first. This one here. So we have x plus 5.5 equals 0. That means x equals to 0 minus 5.5. So cancel this. You are going to get x equals to 5.5, but negative. Okay, so state whether these statements are true or false. Okay, so we need to substitute where there is x. We need to substitute negative 5.5. So this will be 2. Where there is x, right, negative 5.5. Then plus 3. We want to check if the answer we get will be less or equal to negative 5. Okay, so we do first BODMAS. Negative 5 plus 5 is the same as, flip these numbers here, is the same as 3 minus 5.5. And we'll be comparing with negative 5. So this is the same as 2 in the brackets is 3 minus 5.5. This will be negative 2.5. Now, is this going to be less or equal to negative 5? We'll see. So this will be 2 times negative 2.5. This will be negative 5. Okay, now negative 5 is less or equal to negative 5. This is true. Because less or equal has 2 English words. One is less than. So if we use less than, if we use the concept less than, we find that negative 5 is not less than negative 5. But negative 5 is equal to negative 5. So this statement is true because this symbol here, like as I said earlier, has 2 English words. One is less than, another one is equal to. So negative 5 is equal to negative 5. That is true. Okay, let us do this one. X is equal to negative 5.5. Substitute it here. So this will be 3 minus 2 times negative 5.5. Let us compare with 12 and see if this answer will be greater than 12. This will be 3 minus negative times negative is positive. Negative to negative is positive. So 2 times 5.5. Okay, let us see. 2 times 5.5, that will be 11. Okay, now let us see if that will be greater than 12. You find that, let me check that first. 2 times 5.5. Yeah, so we got it correct. So 3 plus 11, because negative to negative is positive. So 3 plus 11, this will be 14. Now, is 14 greater than 12? Is 14 greater than 12? The answer is true. So here, this statement is true. Then let us do this one. Negative 5.5 is the value of x, so substitute it here. You have negative 5.5. Now, so many students will write it like this. This is where they go wrong. So the idea is negative 5.5 is the value of x. So negative 5.5 should be in brackets before you write square. So it should be negative 5.5 in bracket square. Okay, plus x. X is negative 5.5. So we are going to compare with the result if it will be less than 24.75. So is this going to be less than 24.75? So we are going to see. Negative 5.5 square. You can take a calculator and do that. So take a calculator and do that. We have in brackets negative 5.5 square. What is the answer? We have got 30.25. So 30.25 positive times negative will be negative 5.5. Now we'll be comparing with 24.75. Okay, so 30.25 you minus with 5.5. You will get 24.75. Now compare 24.75 with 24.75. You find that 24.75 is not less than 24.75 unless if this symbol was less than or equal to, then our statement could be true. But since this is purely having one English word, that this result we got here should be less than 24.75. So the answer here is false. Okay, so you can pause the video and try to take some working. Otherwise, let us continue. Okay, solve these inequalities. Okay, you may be confused why inequalities while you have only one sentence. Okay, the reason why the instruction is solve these inequalities is because you have two inequalities in one. We have two inequalities in one. One is less than, another one is less or equal to. So solve those inequalities. So you have negative 2 is less than x plus 2 is less or equal to 5. Now, how do we solve this? You may be wondering why I'm leaving some gaps in between. I will show you the use of these gaps. I have left a gap over here and I have left a very big gap over here. So I will show you how do we take use of that gap. Okay, you have two inequalities here. We have this inequality here, and we have this inequality here. Okay, so what we are going to do is we are solving this inequality. We are solving these inequalities. That means we are looking for how much x is. So what we do here is, let me remove this. Okay, this is less or equal to 5. Now, what we are going to do is make x stay alone. That means set x free. Now, how do we do that? What I'm going to do is subtract positive 2. Subtract positive 2 here. And also subtract positive 2 here because we have two inequalities. So what we do on this inequality is what we do on the other inequality. So if this is positive 2, when it goes there it will be minus 2. And this is positive 2. When it goes there on the other inequality it will be minus 2 as well. So this will be minus 2. So positive 2 has been shifted on that side, and also positive 2 has been shifted on that side. So it will be negative 2 minus 2. Now, if that is looking to be confusing, another approach could be this one. Maybe let me move with this approach. This one here. Negative 2. We have negative 2 is less than x plus 2 is less or equal to 5. Let me use this concept here. This is positive 2. This is positive 2. So we are going to subtract. We are going to subtract 2 on both sides. Maybe this can help. Now, positive 2 minus 2, that is 0. Negative 2 minus 2, negative 2 minus 2, this is negative 4. So this on this side here, that will be negative 4. It's less than, this is 0. So only x is remaining there at the middle. It's less or equal to. Now 5 minus 2, minus 2. This will be 3. So this will be 3. Can you see that x is left alone? This is the final solution. So the final solution is negative 4 is less or equal to x is less or equal to 3. Correct. Now, what does it mean? What does this mean? It means that the value of x are all those numbers which are between negative 4 and positive 3. Can you see that? X are all those numbers which are between negative 4 and positive 3. So if we want to show this solution, if we want to show this solution on a number line, there is no problem. What you have to remember is less than, open circle, less or equal, closed circle. Can you see this? Correct. Now, how do we show this? How do we show these two inequalities on the number line? So we are going to have a closed circle just above 3. And we are going to have an open circle just above negative 4. So all the numbers between negative 4 and positive 3, we join them using a ruler. So this is what we are going to do. All those numbers between negative 4 and positive 3, we join them using a ruler. So you take a ruler from here to here. This is what you will be doing. See that? I've chosen like something which is not looking good. Let me choose this. Okay, join the two like so. So this means you are talking about all those numbers which are between negative 4 and positive 3. All those numbers which are less than negative 4. All those numbers which are between negative 4 and positive 3. These are the numbers from negative 4, open circle because of this, and on positive 3, closed circle because of this, less or equal to. Okay, let's continue. Okay, good. Solve the inequalities. Good. The inequalities which we have, let me copy it, negative 6 is less or equal to 3x means 3 times x. That is what it means. Is less than 9. Okay. Now we want to set x free. Now, can you see this is 3 times x? So you do the inverse of multiplication, and that is divide by 3 on both sides. So 3 and 3 will cancel. negative 6 divided by 3, this will be negative 2, is less or equal to 9 divided by 3. 9 divided by 3, this will be 3. Can you see that? Now, suppose the question was to represent this information on the number line. The work could be easy. So what we do, we are going to represent all the numbers on the number line which are between negative 2 and positive 3. This is what it means. All the numbers which lie between negative 2 and positive 3. So what we do, we draw a number line. Okay, we draw a number line. Let's say here, and put all those numbers which are these numbers which are between negative 2 and 3. So the numbers between negative 2, so we have negative 2 here, we have negative 1, we have 0, we have 1, we have 2, we have 3. Maybe let us say this 4, and let us say this is negative 3. But we are interested with negative 2. We are interested with all the numbers which are between negative 2 and positive 3. So we are going to have a closed circle. We are going to have a closed circle here, just above negative 2. Closed circle. And we are going to have an open circle somewhere here. Take a ruler and join that. Join all this. Can you see that? That is a number line for, this is a number line for this solution here. All the numbers which are between negative 2 and positive 3, those are the numbers between negative 2 and positive 3. Those numbers are, you can see negative 1, 0, 1, 2, 3 is not there, but negative 2 should be included by putting a closed circle. So this number line is for negative 2 is less or equal to x is less than 3. This number line you see there. Okay, n is an integer. N is an integer. Remember the discussion about integers? Okay. Write down all the values of n which satisfy negative 6 is less or equal to 3n is less than n. Write down all the values of n which satisfy negative 6 is less or equal to 3n is less than n. Okay, so what did we, if you remember, we saw that negative 6 is less or equal to 3n is less than 9. Write down all the values of n, all values of n, but here we have 3n. So what you need to do, you divide by 3, you divide by 3, you divide by 3. You are going to have by 3, 1, by 3, negative 2, less or equal to, this is n, less than, this will be by 3, 1 by 3, this will be 3. So here, this suggests that the values of n, because n is an integer, now the values of n will be all the numbers which are between negative 2 and 3. But can you notice that this is less than 3? So that means 3 will be excluded. Can you notice this is less or equal to? That means negative 2 will be included in the list. How did I know that these 3 should be excluded? It's because of this symbol, less than. All the numbers which are less than 3. So 3 will be excluded. Here, negative 2 should be less or equal. Less or equal. So the list will begin with the negative 2 itself, the negative 2. And then mention all the numbers which are between negative 2 and 3. Those numbers between negative 2 and 3, starting with the negative 2 itself, will be negative 2. will be -1, will be 0, will be 1, will be 2. 3 will not be in the list because it says less than, but it doesn't say less than or equal to. So 3 will not be there in the list. So it will be all these numbers here. These are the integers. These are the integers they need. Okay. I can pause the video and copy the notes. Otherwise, let us proceed. Solve the inequalities. Okay, solve the inequalities. We have two inequalities. Let me show them. We have 3 less or equal to, that is inequality number 1, less or equal to. Then we have x plus 4 is less than 7. Okay, remember what we discussed? To solve this inequality, we need to set x alone. Just leave x alone. So here we have +4. So what we do? We minus, this is +4. So you do the inverse of addition, that is -4 on both sides. Can you see that? So +4 minus 4, this will be 0, and is leaving x alone here. But what is 3 minus 4? 3 minus 4, this is -1. So this one here is -1. Less or equal to, x is already alone, less than 7. 7 minus 4, this is 3. 7 minus 4 is 3. Okay, now this is the answer. -1 is less or equal to x is less or equal to 3. You can see that x is now free, is now alone. Now suppose you want to draw a number line to represent this information. Can you notice that this is less or equal to 1? Can you see this? -1 is less or equal to 1. So this suggests closed circle above -1. Can you see this? Less than 3. This suggests open circle on or just above 3. So here we are going to have closed circle. Here we are going to have closed circle just above -1. But here we are going to have open circle just above 3. So the number line will be as follows. The number line will be as follows. Okay, so here this will be our number line, and on it we put numbers like -1, should not miss -1, and all the numbers which are between -1 and +3, those numbers are -1, 0, 1, 2, 3. On a number line you can put some more numbers, but we don't need them, because we need to have -1 with a closed circle. So -1 with a closed circle here, just above -1, and you have +3 open circle. And then you take a ruler, you join them. Join that. Join from here to here. See that? This number line is for -1 is less or equal to x is less than 3. Can you see that? So all the numbers between -1 and positive, all the numbers between -1 and positive 3, that's what we are talking about. Now n is an integer. N is an integer. Write down all the values of n which satisfy 3 less than, okay, 3 less than n plus 4 less than 7. Okay, so here we have 3 is less than n plus 4, is less than 7. But now they are talking about n is an integer. Write down all the values. We need to list down all the values of n which satisfy this inequality. Okay, remember what we discussed? Let us first work out what is the value of n. That means let us set n free. This is positive 4, so you minus 4 here, you also minus 4 here, you also minus 4 here. Okay, remember what we said? 3 minus 4 is negative 1, less or equal to positive 4 minus 4. This tends to be 0. So n remains there. It's less than 7 minus 4. 7 minus 4, this is equal to 3. So write down all the values of n. So here we are looking for all the values starting with negative 1. And then we are looking for all the values which are between negative 1 and 3. But remember, this means less or equal, so which suggests to include negative 1 in the list. That is why I'm starting with negative 1 here. So all the numbers which are between negative 1 and 3, including negative 1, exclude that. How did I know that we have to exclude positive 3? It's because of this inequality, which is less than. All the numbers you'll be listing should be less than 3, but not equal to 3. Not equal to 3. Okay. So all the numbers starting with the negative 1, which are between negative 1 and 3, exclude 3, will be negative 1, 0, 1, 2, 3, not in a list, because here they are saying all the numbers which are less than 3, and they lie between negative 1 and positive 3. These are the numbers. This is the list of the numbers. These are the integers required. These are integers required, which satisfy this inequality. I hope that helps. Let's go to next page. Oh, okay. This page now is talking about all the numbers which are between. Can you see that? Open circle, closed circle. This is what I was trying to talk about. You know what it means? Include full. This means exclude negative 1. See, if you are to list the numbers between negative 1 and 4, you are going to include in the list 4 and go all the way up to that negative 1. Okay, now the question is, okay, an inequality is shown on the number line. Let me check properly if there is something I skipped. No, I skipped nothing. Okay, an inequality is shown on the number line. Write down this inequality. Okay, they are talking about inequality. So the inequality will be all the numbers which are between negative 1, all the numbers which are between negative 1 and positive 4. Now, how do we show them? All the numbers which are between negative 1 and 4. So we say those numbers will be represented as x, but those numbers should be less than or equal to 4, because those numbers are not going beyond 4. So all those numbers should be less or equal to 4. Also, those numbers should be greater than negative 1. So this is the way how we show the inequality. So this inequality suggests that all the numbers which are between negative 1 and 4, all the numbers which are between negative 1 and 4, but include 4, exclude -1. If you put less or equal to, that means this will be a closed circle, but that is not a closed circle. So since it's not a closed circle, so the numbers which are between -1 and 4, these numbers are represented as x. So the numbers which are between -1 and 4, these are the numbers they are talking about. And this is the inequality which they want to see. Write down the inequality shown on the number line. That is same story. They are looking for all the numbers which are between -2 and +4. Those numbers which are between -2 and +4 are represented as x. Now x should be less or equal because of that closed circle, and this x should be greater or equal to, not equal to, because we have an open circle, so it will remain like this. So these are the numbers which are between -2 and 4. So this is the inequality. Solve the inequality. This we already discussed. What we do, 2 times y, 2 times 3, so this will be 2y minus 6 is greater or equal to 1. 2y, this -6 will go there, so we're going to have 2y is greater or equal to 1 plus 6. 2y is greater or equal to 7. To find the value of y, we divide by 2, This will be y is greater or equal to 3.5. Okay, what if they ask you, can you show this solution on the number line? Y is greater or equal to 3.5. On a number line is easy. What you do, pull out your number line, put it over here, and here, then this inequality says y stands for all the numbers which are greater or equal to 3.5. So greater or equal to, we'll need to remember closed circle. So all the numbers which are bigger than 3.5. So you start with 3. This is 3. This is for all the numbers which are bigger than 3.5. So I will show you 3, 4, 5, 6, and so on. So y suggests all the numbers which are bigger than 3.5. Now 3.5 is assumed to be here. This is your 3.5. So draw a closed circle. Above that. This is where 3.5 is. Then all the numbers which are bigger than 3.5, that means all the numbers going to this side. These are all the numbers which are bigger or equal to 3.5. This is the number line if they ask you for the number line. Otherwise, if they simply say solve, this you end up here. And if they will need again a number line, then you are good to go for that. Okay, next question is write down the lowest integer which satisfies this inequality. Okay. The solution set we got is y is greater or equal to 3.5. See that? Now we want to write down the lowest integer. Do you remember the integers? Integers are whole numbers. Now can we write down the lowest integer which satisfies this inequality? Which inequality? This inequality here. This answer. So the numbers, the integers which are bigger than 3.5, the integers which are bigger than 3.5 are 4, 5, 6, 7, 8, 9, etc. But what is the question asking for? Write down the lowest integer. So the lowest of all is 4. So here the lowest integer from this list here, the lowest integer is 4. See that? Okay. Okay. Now you may be wondering, I said that when it says greater or equal to 3.5, you have to start with 3.5. But since the question is asking for the integer, 3.5 is a decimal number. Now, a list of integer or a set of integer does not accept integers, does not accept decimals. So that is why I'm not starting with 3.5, because 3.5 is not an integer. Okay, so let us proceed. Oh wow, then we have reached mixed questions. Okay, why did I call mixed questions? It is because in these other pages you'll be getting questions which are mixed up, like they are talking about trial and improvement, at the same time they are talking about inequalities. Okay, so let us proceed. Mixed questions. Decide if these statements are true or false. Tick the correct boxes. Okay. We have 2.3 kilogram, and we have 23,000 grams. You see? So you can't compare if you don't have same units. You can't compare if you don't have same units. One is kilogram, another one is gram. You can't compare that. So what I would suggest is change kilograms into grams, so that we can now see if this statement is true. So let me convert 2.3 kilograms into grams. Okay. The conversion factor is 1 kilogram equals to 1,000 gram. What about 2.3 kilogram? This will be equal to cross multiply. It will be 2.3 times 1,000 divided by 1. So in other words, multiply that by 1,000. This will be 23123, 1 decimal place, 1 decimal place. So this is 2300. Now these are grams. 2300. These are grams. Now you see this inequality given? They are saying this number is not equal to this number. So the answer is false. These two numbers are equal. 150 milliliters is less than 0.3. This symbol stands for less than. Okay, so we have milliliters here, we have liters here. You are comparing two units which are different. So I would suggest changing liters into milliliters. I would suggest changing liters into milliliters. So the conversion factor is 1 liter equals to 1,000 milliliters. How about 0.3 milliliters will be equal to how many liters? So cross multiply. In other words, it will be 0.3 times 1, 0.3 times 1, then divide by 1,000, then divide by 1,000. Okay, this will be 0.3. 0.3 times 1 is 0.3, divided by 1,000. So we have 1 decimal place here, so multiply by 10 here, multiply by 10 here. So 0.3 times 10 is 3. 1,000 times 10, this will be 1,000, then 10. Now we have how many zeros? 1, 2, 3, 4. Count 4 numbers. 1, 2, 3, 4. Then you keep a decimal point over here. So 3 divided by 10,000, the answer is 0 point. So here we have what is that? Let me check. Okay, 1 liter equals to 1,000. 0.3. Oh, this was supposed. We made a mistake over here. Okay, let me correct this mistake. Here we are changing, sorry for that, we are changing liters into milliliters. So 1 liter equals to 1,000 milliliters. Now how about 0.3 liters? will be equal to how much? That means we will be multiplying 0.3 by 1000, and this will be equal to 0.3123, 1 decimal place. So this equals to 300. Oh. Now we are comparing 150 milliliters, compare it with 0.3 liters. This is the same as 300 milliliters. Okay, now we are comparing 150 and 300. Now here it is said this number is less than this number. Is that true? 150 being less than 300? No. So you take false. Okay, we have millimeters and meters. So I would suggest changing the bigger unit into smaller unit. I love that. I love changing smaller units. I love changing bigger units into smaller units. Okay, so the conversion factor will be 1 meter. Meters, millimeters. So 1 meter equals to 1000 millimeters, mm. So how about 5 meters? This you will need to multiply by 1000, and this is 5000. Okay, so we are comparing 5000, this one, with again another 5000. This is 5000 millimeter, this is 5000 millimeter, and they are saying it is expected to be greater, that this number is greater than the 5 meters. Nope, it's not greater, they are equal. So also that is false. Oh, so all answers are false. Okay, yeah, that looks good then. Well and good. Let's go to this question here. This is why I call them mixed questions, because talking about inequalities at the same time is talking about trial and improvement. Okay, this question is talking about Pierre is solving the equation. Pierre is solving the equation x squared plus 4x equals 56. Use a trial and improvement method. Pierre is solving the equation x squared plus 4x equals 56 using a trial and improvement method. The table shows some of his working. Okay, some of his working. Should we check if the working are correct? No need. Complete the table. Oh, we are supposed to complete the table. The table has only 2 blanks. Okay, so what do? We are going to save this function in our calculator. We are going to save this function in our calculator. Ignore this one. This one, ignore that. So save that in our calculator. Okay, how do we do that? We just place alpha, then y equals to, then type alpha x squared plus 4x. Okay, then we're going to calculate. Let me see what is missing. Okay, here we are given the value of x is 5.75. Then we want to see its value. Okay, so we will be substituting. We are going to calculate. We are going to calculate the value of y when x is 5.75. What is the answer? We got 56.0625. So we got 56.0625. Okay. Now, what is the comment? Now, the comment we have to compare with this one here, 56. We got something big. So here we say too big. Complete the final row. Okay, the final row is completed. Now write down the solution to the equation x squared plus 4x equals to 56, correct to one decimal place. Correct to one decimal place. Okay, so what do we do here? Basically, we have to, we got 56.06, this is too big. So basically, we have to proceed with some other trials. Okay, 45, 60, the target was supposed to be 56, and this we got 56 point something too big. So we have to now continue the table to say, let me see if I can get a gap here. 5.75, we got something too big. Now we have to try 5.74. We have to try here, because 5.75, we got something too big. Now here we have to try 5.74. Let's check that. Okay, calculate 5.74. Okay, what is the answer? We got 55.90. Okay, something which is small. We got to 55.909076. Something which is too small. Now, because they have said write down the solution to this equation, correct to one decimal place, we stop here because we have two decimal places over here. We have two decimal places here. Okay. Now, the idea is we are getting some contradiction here. This is 5.75 and this is 5.74. Now, if we round this number, if we round 5, because this is where we are getting answers. This is where we figure out the answers. This is where we figure out the answers. Which value of x will it be equal to? Okay, so here we should be very careful. If we take 5.75, if we round this number correct to one decimal place, we are getting 5.8. If we take this number 5.74, round it to one decimal place, we are getting 5.7. Now, the idea is, should we take 5.8 or should we take 5.7 to be the solution, to be the value of x? Now, this is where we need some logical thinking. Here we were expecting to get the answer which is equal to 56, but here we got 56.0625, which was too big, and then here we got 55.9076, which is too small. You see? So we want to see 56.0625 compare with 56. How big is this number? How big is this number? So what do? We take 56.0625 minus with the expected answer 56. What is the difference? The difference is 0.0625. So here we are getting a difference of, compared with this 56, compared with 56, we are getting a difference of 0.625. Can I check? Or difference of 0.0. So a difference of 0.0625. Okay, now let us compare 56 with this 55. How small this number is. Okay, how small that number is. So you take 56 minus 55.9076. How small is that number? The number is 0.0. See that? 0.0924. Okay, the difference is 0.0924. Okay, so the difference is 0.0924. Okay, now which one is a little bit close to 56? This one has a difference of 0.0625 higher, and this is 0.0924 lower than 56. So this was 0.0625 higher than 56, and this is 0.0924 lower than 56. So we go for this. We go for this one. 5.75. 5.75. When we correct that to 1 decimal place, the answer will be 5.8. See that? So here the answer will be x equals 5.8. This is the answer. All right. Let me check how many minutes. I worked out 52 minutes. It's not bad. Okay. This question is talking about Anastasia. Anastasia is 8 years old. Bless is B years old, and Manjit is M years old. Now the question is, Bless is older than Manjit. Okay, Bless is B years, is older than, that means is older than Manjit. Manjit is M years. This is the inequality which we are supposed to connect the age of Bless and the age of Manjit. Now draw a ring around the correct inequality. Okay, this is the inequality I have figured out. Older means greater. Okay, so we should not forget that. Those are English words. So draw a ring. This is where we draw the ring. B greater than M. So this is where we draw a ring. Okay. Oh, we are done. Anastasia is less than half the age of Bless. Anastasia, what is the age of Anastasia? Is A. Okay, Anastasia, the age of Anastasia is less than half. Is less than half the age of Bless. Anastasia is less than half the age of Bless. Okay, what is the age of Bless? Let me check. Bless is B years. Okay, so Anastasia is half the age of, so half of the age of Bless. So it will be looking like this, because Bless is B years and Anastasia is A. So write this inequality. Write this statement as an inequality. So this is the answer. This is the inequality. So easy. Okay. So you can pause the video and take note of that. Otherwise, let us proceed. The diagram shows a trapezium. Okay, this is a trapezium. Okay. The area of the trapezium is 30 centimeters square. A and B are both whole numbers with A less than B, or A should be less than B. That means B should be longer than A. Okay. Work out one possible pair of values for A and B. Okay. We go back to the formula which says area of a trapezium. So area of a trapezium equals to half the sum of A and B 10 times height. Okay, area is 30. Okay, area is 30 centimeters squared. So ignore the centimeter, ignore the centimeter, ignore the centimeter, ignore the centimeter square. So area is 30 equals to half. We don't know the value of A, we don't know the value of B, but we are given that A is any number less than B. Okay. But how about the height? The height is 6. See that? The trapezium is 6 centimeters high. So you put 6 there. So these 2 can simplify with this 3. That equals to 3. So this will be 30 equals to A plus B multiplied by 3. Now, A plus B should be left alone because we are comparing A and B. So find the inverse of multiply by 3. This will be divide by 3. Divide by 3 so that we can compare A and B. So this will be like that. 30 divided by 3, this is 10 equals to A plus B. See that? Now, how do we do reasoning? To find the possible pair of values for A and B, we need to do reasoning. It is known that A and B are both whole numbers. That means not decimals. Not decimals. They are whole numbers. But with the condition that A should be less than B. Now work out the possible pair of values for A and B with the condition that A should be smaller than B. Okay. But put in your mind that A plus B, you see that? A plus B should be equal to 10. Now with A less than B, the possible pair of the value of A and B, the possible pair will be A should be equal to 4 and B should be equal to 6. See, A is 4, B is 6. 4 is less than 6. See that? A is 4, B is 6. Can you see that 4 is less than 6? Okay, but from here they said only one pair. So only one pair. What if I need so many pairs? I can say A will be equal to 2. Now when this is 2, 2 plus a certain number should be giving 10. So B will be equal to 8. Because 2 plus 8 equals 10. I can get another pair. A equals 1. B will be equal to 9. Because 1 plus 9 should be equal to 10. You have another possibility? You can find out. But they need only one pair. So I will go for A is 4, B is 6. See that? Good. Let us see if we can stop here, and I'll be back for the last video, which will be part 3. And this will take us, that will be the last video. Otherwise, bye-bye for now, and I'll be back later. Bye.